In developing a statistical analysis plan for a research, after we have completed step 1 in drafting mock abstract, in step 2, we expand the mock abstract to a mock manuscript. So I paste the structure of an abstract here on the left hand side. And in step 2, when we talk about expand, that means in the problem statement, it will be expand to the first sections of the mock manuscript, which is the introductions. Actually, there is no heading for that in the mock manuscript. These sections following the abstract. So it's about half a page for introduction, or maybe up to 1 page. It's not so long. So each item here become a paragraph in this section. So approximately it's about 3 paragraphs. Then for the method sections, we copy first and then expand to 1 to 3 pages. So it followed these sections also in the mock manuscript. Start with the first paragraph, or it could be a subheading about type of the study design, the sample size, and sample selection usually come at the end of this method section before the statistical method for the analysis. So study design followed by outcome and outcome measurements. All right, and statistical sections come to the last of this section. So it's about 1 to 3 pages long. For results from the abstract, it is a narrative and select some to present there. But for the mock manuscript, this section expand quite long, like 1 to 5 pages. There are about 1 to 2 figures approximately, 2 to 4 tables, not much. So these are called the dummy table or figures in the mock abstract. Sorry, the mock manuscript. And for the conclusions in the mock manuscript, it's become a section called discussions, and the conclusion sections is a paragraph at the last of these sections. So usually the discussion sections of the mock manuscript have a structure, which I will talk in details about writing session in the future. But I can say it here that we copy from the mock abstract to this, that to preserve consistency with the abstract. This one will be at the end of the sections here. And the first section usually it's explain the finding, summarize the findings from the results and explain it, and then highlight about the strength and weakness of the study, and then the conclusion, as I said. So it's take about 5 to 10 pages long for the mock manuscript. That means expand this one, and then the reference at the end, about 10 to 30 references for each manuscript. Okay, so here is step 2. Then you may feel a bit clearer about how we develop the statistical analysis plan, because from the abstract we know that it's embedded there, and then when it become longer in just like a report, but in the format called manuscript, you will see more details, and this will guide closer to the statistical analysis plan. For this step, I will just make it short like that, because we will go to the step 3, and then you will see a whole picture. And at the end, I will show you the example of real-life practice for doing clinical research. Then I will emphasize part about the dummy tables and figures to allow you to touch about the previous sections that I emphasized about the importance of the primary outcome. So I will show you about the dummy table of the main findings that should be presented in the results section. 4 examples according to the 4 types of the outcome. The first one is continuous outcome. So this one is the title. And as an example, factors affecting body weight, to make it general and have some explanations that allow you to see how it these variables should be handled. So the first things after we know about the continuous outcome is we playing with mean. We summarize the continuous variable using mean. All right. Except if the data is highly skewed, we will play around the median, but median has less efficiency than mean, so usually we have some data handling to be able to use mean. For example, with data transformation, if not success, we will use some other appropriate method, and median is one of that choice. I will not go in details here. For now, continuous outcome, go for mean. So the magnitude of effect, the effect measures for continuous outcome is the mean difference. Based on what method? Multiple linear regressions, if you can recall my previous slide. And then the left-hand side is list of variables that related to the research question, and then I make it just for you here that this one is the dichotomous, this one is polytomous, this one also polytomous, but actually it is continuous and we categorize it. So continuous can be handled by categorization according to some meaningful cut point, or by continuous as it is in every 1 year or every 5 years or every 10 years, it's like that. So the second column is the sample size, the size of each group, the number of subjects per each group, and followed by the mean and the standard deviations, which is the important summary of the continuous data. Without n, this is less meaning. Without standard deviation, is not complete. So that is why we have this type of presentations for this. And then when we compare between groups, which is male and female, we need one group as the reference to get the mean difference. So we have only one mean difference for dichotomous, but we have two mean differences for polytomous, like 3 groups here. One is the reference group. This one is just to show the audience that if we consider one factors at a time, how large is the effect? Okay, so now this is from the simple linear regressions. I mean, from the bivariate analysis, where in the model we have only one factor, one independent variable in the model. The next column here is the adjusted mean difference from the multivariable analysis. That means this column will need to transcribe from the output of the model that containing all variables here. So that is multivariable analysis, or from multiple linear regression. So that means it's adjusted for other factors in the table, unless you specify otherwise. If you handle something like this part could be just exploratory of this, not necessary to be like this in real practice. And the confidence interval, 95% confidence interval for the adjusted mean difference, and the p-value. So these type of tables, just to illustrate how we present the data for the main findings, or the main findings of the research with a continuous outcome. And other type of outcome will also resemble this, but change from, rather than mean, to other summary measures that correspond to that type of variables. So if you understand this one, you can apply to any type of variables. One thing that I like to show you is, even we use mean, you see, we have 2 mean at the beginning, and then the difference here, for example, if this one is 2, if we have this column, we will know that it's 2 from 4 minus 2, or from 80 minus 78. You know, if we present only 2 without presenting the 2 means that make the difference as 2, we will have no information about how large of the 2. For example, if 4 minus 2, it is at about 50%, you know. So it's about 50% of the reference. So, but if 80 minus 72, it's just a very few percentage. You see, it's really meaningful if we show this. That is essential. That's the first one I like to mention. The second one is, if we have 2 mean, the 2 number can do things, mathematical operations, about 4 methods: plus, minus, divisions, and multiplications. For comparing the multiplications and the plus, cannot provide any measures for comparison. So we have only 2 choices: minus or divisions. The minus is the difference. The divisions make it as a ratio. So for mean, usually we present it as the difference. The ratio is rarely used, except we playing with the mean difference that is transform unit, like log transformations. Then the difference of the log become the ratio. So that in a rare case, we present a ratio for continuous outcome, mostly a mean difference. Okay, that's the two things that I like to remark. The second type of outcome is categorical. Now I just show you about dichotomous outcome just to let you see the differences between this type and the continuous. So for continuous, you see this? Exactly the same for the first one and two column, but the third one changed from mean to percentage, you see? Percent of what? Percent of the outcome. So factors affecting hypertension. Hypertension is the outcome. So here we need the percent of the event or the outcome. It's derived from the numerator, which is the number of hypertension divided by the total subjects in each group. But we no need to present the number of people who have hypertension. The numerator no need, because it's view redundant with the information here, because if we know the percentage of hypertension, you know the total number that is the denominator, we will know about the numerator or number of hypertension patients. So only two columns to describe that. Again, without n, there is not complete meaning. For example, 50% here hypertension, if it's come from only 2%, you know, it will less meaning at all, something like that. So this is very important. Many papers did not present this, so I like to remark this. Then, from multiple logistic regressions, which is the common methods for categorical, like dichotomous outcome here, the measures of the effect is odds ratio. I mean, the coefficients of the logistic regression model is the odds ratio. So we have this, just like the mean difference, but now the OR, odds ratio, and also the same here, adjusted odds ratio, confidence interval, p-value. Okay, in some case, if we have a research question like this, rather than to have the odds ratio, we can have like the risk ratio or RR using another method called generalized linear model or binomial regression. Okay, it's generalized model. Or it could be the risk difference. You know, rather than using the divisions, we can use the subtraction, which is derive the mean, the risk difference or RD. So I just expand from this. All the choices that I have mentioned, it really depends on the researcher. In some researcher give all, but some select only the one that they propose. Whatever it is, it needs to be planned in advance. So that is why we need to have the statistical analysis plan at the beginning before we see the data. Okay, this is the second type. The third type is the numerical count or the Poisson count outcome. Say, factors affecting hospitalizations among elderly. So for this, the hospitalization seems to be the dichotomous, but actually we cannot handle as dichotomous because some participants might have more than one hospitalizations across the durations of observations. So we will use count of the episode of hospitalizations as the outcome, and then here is how to draw a dummy table. It's the same for the first two columns, but add one more here because we will not use only the number of participants in each group as the denominator to get the rate, called the incidence rate. But we will use the total person time. For example, if we follow 10 persons, for example here, in total for 300 person month, this will be the denominator to get this. So this one, the incidence rate is come from the number of episodes, total number of episodes of hospitalizations divided by the total person times. So this then multiplied by 100 become 100 person month. And then compare this using the incidence rate ratio, which can be obtained from the coefficients of the multiple Poisson regression model, the same way as the previous type of model. And the last one, survival outcome or event-free durations, say factors affecting first stroke among CKD patients. Okay, so the event-free durations here is free from stroke, starting from the being diagnosed as having CKD. The same way, the first two columns is the same as the previous one. The fourth one is just like a Poisson model for numerical count. Because there are durations of observations involved here as well. This will give an idea that when we use the multiple Cox regressions to analyze the data and the coefficients of the model give us the hazard ratio or HR here. So for example, if we have 2, this is the approximate from a Poisson approach, but actually it will be the hazard ratio derived from another method, which is from the Cox model. So it just allowed the audience to know about 2 here is from about approximate 4 divided by 2 or 80 divided by 40, for example. So this is the ratio because we have no rate, no hazard rate here. We use this one instead. Okay, so the adjusted one is from the multiple Cox regression, and the same for all others. Here are the 4 types of outcome that provide example of the dummy table for the study with the title of this kind. Mostly just like this, but there might be some small difference other than this if we have a specific purpose, not like factors affecting or effect of X on whatever. Okay.